April 15th, 1944. 26,000 feet above Hanover, Germany. First Lieutenant Robert S. Johnson of the 56th Fighter Group pulled his P-47 Thunderbolt into a tight turn, tracking a Messerschmitt Bf-109 through his gun sight. His thumb pressed the firing button, sending 8 streams of 50 caliber rounds toward the enemy fighter. The German pilot, realizing his peril, threw his aircraft into a desperate dive. Johnson followed, the massive 7-ton Thunderbolt gathering speed as it plunged toward the cloud deck below. At 22,000 feet, Johnson's pursuit was suddenly interrupted by a sharp crack and violent shudder that rocked his aircraft. Glancing to his right, he saw something impossible. Roughly 6 feet of his wing was simply gone, sheared away cleanly. A Focke-Wulf 190, appearing from his blind spot, had raked the P-47 with cannon fire. I remember feeling nothing but disbelief. Johnson would later write in his memoir, "Half my wing was missing, yet the Thunderbolt kept flying. Any other aircraft would have immediately rolled over and plunged to earth. Instead, the massive fighter, nicknamed the Jug for its bulbous, milk jug-like fuselage, remained controllable, responding sluggishly but obediently to Johnson's inputs. The pilot turned toward England, 300 miles distant, uncertain if his crippled aircraft could make the journey home. What followed would become one of the most remarkable demonstrations of aircraft survivability in the history of aerial warfare. Johnson's return flight, accomplished on a wing and a prayer, quite literally, would vindicate Republic Aviation's engineering philosophy and transform the reputation of a fighter aircraft that many had initially dismissed as too big, too heavy, and too ungainly for modern air combat. The unwanted juggernaut. The journey of the P-47 Thunderbolt began in the late 1930s when Republic Aviation's chief designer, Alexander Kartveli, set out to create a lightweight interceptor. But as war clouds gathered over Europe, the Army Air Corps' requirements shifted dramatically. By 1940, the lightweight design had evolved into something altogether different, a massive, powerful fighter unlike anything the world had seen. When the first prototype XP-47B rolled out in May 1941, the reaction was a mixture of awe and skepticism. Weighing over 7 tons fully loaded, the P-47 was more than twice as heavy as the Supermarine Spitfire. Its wingspan stretched to 40 feet, and its length exceeded 36 feet. At its heart thundered the most powerful aircraft engine then in production, the Pratt & Whitney R-2800 Double Wasp, an 18-cylinder radial monster producing 2,000 horsepower. Major General James Doolittle, who would later command the 8th Air Force, recalled his first impression. "It looked like the largest single-engine fighter I had ever seen. The question was whether something that big could actually fight." This skepticism extended across the Atlantic. When the first P-47Cs arrived in England in December 1942, British pilots and commanders viewed the American fighter with barely concealed derision. "It's not an aircraft. It's a bloody great lorry with wings," remarked one RAF squadron leader after examining the massive fighter at Bovingdon Airfield. The Germans, who would soon face this American giant in combat, were similarly dismissive when their intelligence services provided reports and photographs. Luftwaffe ace Adolf Galland reportedly quipped, "The Americans have clearly confused quality with quantity. One cannot fight effectively in a flying safe." Even American pilots assigned to the first P-47 units harbored doubts. Captain Don Blakesley, who would later command the 4th Fighter Group, commented after his initial training flights, "The damn thing flies like a bathtub. Give me a Spitfire any day." These early impressions seemed justified by the P-47's initial combat performance. When the 56th and 78th Fighter Groups began operations from England in April 1943, their first encounters with the Luftwaffe yielded mixed results. The P-47 proved fast in a dive, reaching speeds over 500 miles per hour, but its rate of climb and high-altitude maneuverability didn't match the nimble German fighters. The massive fighter consumed fuel at an alarming rate, limiting its combat radius to barely 150 miles. But it was the Thunderbolt's sheer structural strength that most impressed those who flew it in combat. Republic Aviation had built the aircraft with a massive spar running through each wing, capable of supporting loads far beyond normal combat stresses. The fuselage was similarly overbuilt, with structural members that could withstand severe battle damage. Colonel Francis Gabreski, who would become America's leading European theater ace with 28 aerial victories, initially shared the common skepticism. When I first saw the P-47, I thought it was a joke. How could something that big and heavy be an effective fighter? But after my first combat mission, I changed my mind completely. The 8 guns were devastating, and the airplane took hits that would have downed anything else I'd ever flown. By mid-1943, as combat experience accumulated, the Thunderbolt's reputation began to transform. Pilots returned from missions with aircraft showing incredible battle damage. Holes through wings and control surfaces, engine cowlings riddled with bullet impacts, tail assemblies partially shot away, yet the massive fighters continued flying. Maintenance crews marveled at the punishment these aircraft could absorb while bringing their pilots home safely. 2. Engineering a survivor. The P-47's extraordinary survivability was no accident. It resulted from deliberate engineering decisions made by Alexander Kartveli and his team at Republic Aviation, reflecting hard lessons learned in earlier air combat. Kartveli, a Georgian immigrant who had fled the Russian Revolution, brought a pragmatic philosophy to aircraft design. An airplane that cannot survive combat will not win wars, no matter how maneuverable or fast it might be, he reportedly told his engineering team. Our fighter must bring the pilot home, even when damaged. This philosophy manifested in numerous features that distinguished the Thunderbolt from its contemporaries. The cockpit sat nestled behind the massive engine, which served as additional protection for the pilot. Behind and below the pilot, a heavy armor plate shielded against attacks from the rear. The pilot himself sat within a tub of half-inch steel armor that could stop 20mm cannon shells. The control systems incorporated redundancy at every level. The P-47 featured duplicate control cables running to all major control surfaces. If one cable was severed by enemy fire, the backup would maintain functionality. Hydraulic systems were similarly protected, with bypass valves that would isolate damaged sections to prevent loss of pressure. The fuel system represented another triumph of survivability engineering. The P-47's main fuel tank, located behind the pilot, incorporated multiple layers of self-sealing material. When bullets penetrated the tank, the inner rubber layer would swell upon contact with fuel, sealing the hole within seconds. This technology, while adding considerable weight, saved countless pilots and aircraft. Perhaps most crucial was the P-47's radial engine. Unlike the liquid-cooled inline engines used in many fighters of the era, which could be disabled by a single bullet puncturing the cooling system, the air-cooled R-2800 had no vulnerable radiator or coolant lines. Individual cylinders could be shot away while the engine continued to function on the remaining ones. Pilots reported returning to base with up to 6 cylinders destroyed or inoperative. Lieutenant Colonel Morton McConnell, Chief Maintenance Officer for the 56th Fighter Group, wrote in a technical report, The double Wasp engine in the P-47 routinely returns aircraft to base, despite damage that would render other power plants completely inoperative. We have documented multiple cases where 5 or more cylinders show combat damage, yet the engine maintained sufficient power for sustained flight. By late 1943, as experience with the Thunderbolt accumulated, Republic began incorporating additional survivability features based on combat feedback. Armor protection increased around vulnerable components. Fuel capacity expanded with protected auxiliary tanks. Self-sealing lines replaced vulnerable rubber hoses throughout the hydraulic system. General of the Luftwaffe Adolf Galland, who had initially dismissed the P-47, revised his assessment after months of combat reports from his pilots. The Thunderbolt represents a different philosophy of fighter design than ours. While we emphasized maneuverability and firepower, the Americans prioritized ruggedness and survivability. In prolonged combat, their approach has proven more effective than we anticipated. This evolving respect among German pilots stemmed from repeated frustrations. Luftwaffe ace Heinz Baer described one such encounter in October 1943. "I closed on a P-47 from behind and put at least 20 20mm cannon shells into its fuselage and right wing. Pieces flew off, but it did not go down. It rolled into a dive, and I could not follow due to fuel concerns. These aircraft simply refused to die." Number 3. The Wolfpack transforms the air war. While the P-47's durability was being proven in combat throughout 1943, a parallel development was transforming its tactical effectiveness. Colonel Hub Zemke's 56th Fighter Group, soon nicknamed the Wolfpack, pioneered techniques that maximize the Thunderbolt's strengths while minimizing its weaknesses. Zemke, a former engineering student with a methodical mind, analyzed early combat reports and recognized that conventional dogfighting tactics were ill-suited to the massive fighter. "The P-47 is not a ballet dancer," he told his pilots during a tactical briefing in June 1943. "It's a heavyweight boxer. We don't dance with the enemy. We hit them hard, use our speed and diving power, then climb back up for another pass." This approach evolved into the dive-zoom-dive tactic that became the Wolfpack's signature. P-47 pilots would patrol at high altitude, often above 30,000 feet, where the turbo-supercharged engine provided full power. When enemy aircraft were spotted below, the Thunderbolts would dive at maximum speed, make a single firing pass, then climb back to altitude using the tremendous energy gained in the dive. From this regained height advantage, they could dive again or withdraw, as the tactical situation dictated. Major Robert Johnson, who would survive his half-wing flight in April 1944, described the psychological impact of these tactics. "The Germans never knew what hit them. We'd come screaming down at over 500 miles per hour, make one devastating pass with all 8 guns blazing, then be gone before they could react. It was boom and zoom, hit and run at its most effective." The devastating firepower of the P-47's 850 caliber machine guns proved crucial to this approach. While German fighters typically carried a mix of 7.92mm machine guns and 20mm cannon, the Thunderbolt's concentrated pattern of heavy machine gun fire could tear apart an enemy aircraft in a second-long burst. Each of the 8 guns fired at a rate of 800 rounds per minute, meaning a 1-second trigger press sent more than 150 caliber projectiles toward the target. Lieutenant Colonel Francis Gabreski recalled, "With the P-47, you didn't need to get in behind an enemy and stay there, pumping rounds into him. One good burst from those 850s would rip a Messerschmitt apart. I saw wings separate, cockpits disintegrate, engines torn from mounts, all from short bursts at high speed." Zemke's tactical innovations extended to formation flying as well. He developed the Zemke fan, a spread formation that allowed flight members to watch each other's blind spots while covering more airspace. This arrangement made ambush much more difficult for German fighters and allowed the Thunderbolts to quickly pair up for mutual support when engaged. As these tactics evolved, the 56th Fighter Group's victory tally climbed steadily. By the end of 1943, they had claimed over 200 enemy aircraft destroyed, establishing themselves as the premier fighter unit in the 8th Air Force. Their success attracted attention at the highest levels, with General Hap Arnold, commanding general of the Army Air Forces, visiting Boxted Airfield in November 1943 to observe their operations firsthand. The 56th's success contributed to a broader reevaluation of the P-47's role in the European Air War. By early 1944, Republic had delivered over 5,000 Thunderbolts, with production rates exceeding 300 aircraft per month. This industrial might allowed the 8th Air Force to equip 15 fighter groups with the massive fighter, creating an aerial armada that the Luftwaffe increasingly struggled to counter. German pilot Werner Schröer, who would claim 26 victories over American aircraft, described the psychological impact in a post-war interview. The Americans seemed to have endless supplies of these massive fighters. Shoot one down, and 10 more appeared. Damage one, and it would still return to fight another day. It created a sense of futility among many of our pilots. 4. The Desperate Hours. April 15, 1944. 26,000 feet above Hanover, Germany. First Lieutenant Robert Johnson's day had begun like many others. A pre-dawn briefing, a cold breakfast, and the tense climb into the cockpit of his P-47D Thunderbolt, half and half. As deputy leader of the 62nd Fighter Squadron, part of Zemke's 56th Fighter Group, Johnson had already amassed 16 confirmed aerial victories, placing him among the leading American aces in the European theater. The morning mission targeted the Luftwaffe airfield at Hanover, with the 56th assigned to suppress enemy fighters that might threaten the bomber stream. Johnson's flight of 4 Thunderbolts had separated from the main group to investigate contrails spotted to the northeast. What followed was a swirling dogfight with a dozen Messerschmitt Bf-109s from JG-26, the famed Abbeville Kids fighter wing. Johnson had just fired a burst that sent one German fighter smoking toward the deck when his Thunderbolt absorbed a devastating hit. The impact felt like a giant hammer striking the aircraft. Johnson would later write, "No alarm, no warning, just a massive blow followed by violent shuddering." Hauptmann Wilhelm Ferdinand Galland, younger brother of the famous Adolf Galland and a skilled pilot in his own right, had slipped his Focke-Wulf 190 beneath Johnson's Thunderbolt. A precise burst from the German fighter's 20mm cannons sheared through the P-47's right wing, removing approximately 6 feet of the structure in a single devastating blow. Johnson's immediate reaction was automatic. Stick forward to prevent a stall, gentle pressure on the rudder to counter the asymmetric lift. Through skill and instinct, he stabilized the crippled fighter, but the immediate question remained. Could he fly the 300 miles back to Boxted Airfield in England? The massive Thunderbolt shuddered and vibrated, its normally precise handling replaced by a sluggish, wallowing response to control inputs. The right wing, now dramatically shortened, generated far less lift than the intact left wing, requiring constant left aileron and right rudder to maintain level flight. "Every instinct told me to bail out," Johnson recalled. "Logic said this aircraft couldn't possibly remain airborne for the 2-hour flight home. But something else, trust in the Thunderbolt's design, perhaps, made me decide to try." That decision initiated one of the most remarkable demonstrations of aircraft survivability in the war. Johnson nursed the damaged fighter onto a westerly heading, gradually descending to find denser air that would provide better control. He shut down all non-essential electrical systems to conserve battery power and carefully monitored the engine gauges, watching for signs of damage that might not be immediately visible. The P-47's massive R-2800 engine continued its reassuring rumble, its 18 cylinders seemingly unaffected by the structural damage to the airframe. Johnson maintained a speed of 160 miles per hour, significantly faster than normal cruise to compensate for the reduced lift from his damaged wing, but slow enough to minimize stress on the compromised structure. As he crossed the German border into occupied Holland, Johnson spotted two Beef 109s climbing to intercept. With his crippled aircraft, combat was unthinkable. He pushed the damaged Thunderbolt into a shallow dive, accelerating away from the threat. Remarkably, despite the missing wing section, the P-47 maintained structural integrity even as airspeed increased to over 300 miles per hour. "I expected the remainder of the wing to tear away at any moment," Johnson wrote. Instead, the Thunderbolt accelerated as if determined to outrun its pursuers despite its wounds. The German pilots, apparently unwilling to pursue the damaged American fighter toward the English Channel, where Allied air patrols might be encountered, broke off their chase. Johnson continued westward, alone and increasingly tired from the constant physical effort required to keep the asymmetric aircraft level. 5. The revelation of American industrial might over the North Sea. New challenges emerged for Johnson. Weather conditions deteriorated, with cloud banks forcing him to fly on instruments, a difficult task even in an undamaged aircraft. The constant vibration had caused his compass to malfunction, forcing reliance on dead reckoning. Fuel consumption, increased by the abnormal flight configuration, became a growing concern. "I remember calculating my fuel status every few minutes," he recalled. The gauge showed I was burning nearly twice the normal amount, making landfall in England increasingly uncertain. As fuel levels dwindled, Johnson faced the grim prospect of ditching in the frigid North Sea. Survival rates for pilots who went down in these waters were dismally low, with hypothermia claiming those who weren't injured in the landing. He prepared mentally for this possibility, reviewing ditching procedures while continuing to nurse maximum range from his remaining fuel. 2 hours and 17 minutes after taking the devastating hit, Johnson glimpsed the English coastline through breaks in the clouds, a sight he had doubted he would ever see again. With less than 20 gallons of fuel remaining in tanks that normally held 370, he made contact with RAF Manston, an emergency airfield on the Kent coast, equipped for battle-damaged aircraft. "Mayday, Mayday. P-47 with severe wing damage. Request immediate landing clearance," he radioed. The controller's response reflected disbelief. "American P-47. Confirm nature of your damage. Missing approximately 6 feet of my right wing. Aircraft controllable, but unstable." After a brief pause came the reply. "Understood, P-47. You are cleared to land. Emergency vehicles standing by." The landing itself would require all of Johnson's skill and the Thunderbolt's remaining structural integrity. He approached at 180 miles per hour, 40 miles per hour faster than normal landing speed, to maintain control authority over the damaged aircraft. The increased speed meant he would need every foot of Manston's runway. "I knew I had one chance," he later wrote. "Come in too slow, and the damaged wing would stall, flipping the aircraft uncontrollably. Too fast, and I'd run out of runway or blow the tires on landing." Johnson touched down firmly, immediately cutting power and applying brakes. The Thunderbolt rolled for nearly 3/4 of the runway length before finally coming to rest, fuel tanks nearly dry. the massive fighter finally safe on English soil. When Johnson climbed down from the cockpit, legs shaking from exertion and adrenaline, he was met by wide-eyed ground crew who simply stared at the damage to his aircraft. The clean shear through the right wing revealed internal structures and control cables, with the aileron entirely gone and the flap mechanism partially exposed. Wing Commander Ian Gleed of the RAF, who happened to be at Manston that day, examined the damage and turned to Johnson. No other fighter in existence could have flown with damage like this. You Americans have built something truly remarkable. Johnson's flight, remarkable as it was, represented just one episode in a larger transformation of aerial warfare driven by the P-47 Thunderbolt. Behind each fighter that reached the front lines stood an industrial colossus unlike anything the world had seen before. Republic Aviation's main production facility at Farmingdale, Long Island, had been a modest operation before the war. By 1943, it had transformed into a manufacturing behemoth with over 24,000 workers operating around the clock. Massive assembly lines stretched nearly a mile, with partially completed Thunderbolts moving steadily from station to station as components were added. A second production facility at Evansville, Indiana, added further capacity, enabling Republic to achieve production rates that astonished even American planners. By mid-1943, Thunderbolts were rolling off assembly lines at a rate of 1 aircraft every hour, 24 per day, 7 days a week. This production miracle reflected American industrial capacity that German leadership had fatally underestimated. While the Luftwaffe struggled to replace losses, with monthly fighter production rarely exceeding 500 aircraft across all types, Republic Aviation alone was delivering over 600 Thunderbolts per month by early 1944. Reichsmarschall Hermann Göring, commander of the Luftwaffe, reportedly refused to believe early intelligence reports about American production rates. It is physically impossible to build complex fighter aircraft at such rates, he told his staff in late 1943. These figures must be propaganda. When confronted with photographic evidence of the Republic factories and the streams of new Thunderbolts arriving in England, Göring finally grasped the scale of what Germany faced. In a meeting with Hitler and Armaments Minister Albert Speer in January 1944, he conceded, "The Americans are not simply outproducing us. They inhabit an entirely different scale of industrial capability." This revelation extended beyond raw production numbers to the quality and consistency of the aircraft being delivered. Each Thunderbolt underwent rigorous testing before acceptance, including full-power engine runs, systems checks, and test flights. Defects were tracked and analyzed, leading to continuous refinements in the production process. The contrast with German production methods was stark. As the war progressed and Allied bombing disrupted German industry, Luftwaffe fighters increasingly suffered from quality control issues. Pilots reported engines that failed prematurely, structural weaknesses, and inconsistent performance between supposedly identical aircraft. 6. The mathematics of defeat. Johnson's remarkable flight became a symbol of the Thunderbolt's durability, but thousands of other P-47 pilots experienced similar, if less dramatic, demonstrations of the aircraft's survivability. By mid-1944, maintenance statistics compiled by a 8-fighter command revealed a compelling narrative. P-47s were returning from combat with battle damage at a rate of 75% higher than any other fighter type, yet their loss rate was 20% lower. Captain Howard Park, an intelligence officer with the 56th Fighter Group, compiled reports of severe battle damage from which Thunderbolts had recovered. His findings astonished even veteran pilots. 127 documented cases of aircraft returning with major structural damage to wings or tail. 63 instances of P-47s flying home with one or more cylinders completely destroyed. 39 cases of control surface loss exceeding 30% of area. In any other fighter type, these would have been fatal hits. The cumulative psychological impact on German pilots became increasingly evident in Luftwaffe combat reports and prisoner interrogations. Major Hans-Joachim Jabs, commanding 3, JG-27, instructed his pilots in February 1944. The Thunderbolt will not go down with a single burst, even from cannon. You must continue firing until the aircraft shows clear signs of going down, smoke, fire, or structural failure. Otherwise, assume it will return to base. This durability translated directly into pilot survival rates. By mid-1944, 8th Air Force statistics revealed that P-47 pilots had a 78% chance of surviving being shot down, either by successfully crash-landing their damaged aircraft or by safely bailing out. This compared to a 56% survival rate for pilots of other fighter types. The additional seconds or minutes that a damaged Thunderbolt could remain airborne often meant the difference between capture and death for its pilot. Colonel Hub Zemke put it bluntly in a letter to Republic Aviation. "Your aircraft is saving hundreds of American lives. We have pilots walking back into the briefing room who, in any other fighter, would be dead or prisoners of war." The confidence this gives a man going into combat cannot be overstated. This survival advantage affected not just individual pilots, but the broader prosecution of the air war. While the Luftwaffe lost irreplaceable veteran pilots at a catastrophic rate, American fighter groups maintained a core of experienced airmen who passed their knowledge to newcomers. By late 1944, the average Luftwaffe pilot had less than 100 flight hours before entering combat. His American counterpart typically had over 400 hours, plus the benefit of learning from squadron mates who had survived dozens of combat missions. Lieutenant Colonel Glenn Duncan, who commanded the 353rd Fighter Group equipped with Thunderbolts, described this cumulative advantage. "The Germans were consistently losing their best people, their equivalent of our Zemkes, Gabreskis, and Johnsons. We kept ours, who became not just combat leaders, but teachers. Each surviving veteran pilot improved 10 others around him." The numerical disparities became increasingly overwhelming. By D-Day in June 1944, 15 fighter groups operating P-47s gave the 8th Air Force over 1,000 of these fighters in England alone. Against this, the Luftwaffe could field approximately 700 fighters of all types across the entire Western Front, with perhaps half that number operational on any given day. The Reich Air Ministry's production reports tell the story of a nation falling hopelessly behind. In 1943, Germany produced 7,725 fighters of all types. In that same year, Republic Aviation alone built 5,222 Thunderbolts, and this represented just one fighter type from one American manufacturer. German aircraft designer Kurt Tank, creator of the formidable Focke-Wulf 190, visited a captured P-47 at a test facility near Munich in early 1944. His assessment was sobering. "This aircraft reveals a manufacturing capacity beyond anything we can match. The aluminum forgings, the quality of the welds, the consistency of the riveting, all speak to a level of mass production sophistication that German industry cannot hope to equal under current conditions." Field Marshal Erhard Milch, responsible for Luftwaffe production, similarly concluded after reviewing American aircraft manufacturing data. "The battle is lost. We cannot match even 10% of American aircraft production. Each month, they build more fighters than we can produce in half a year." Darkchancer 7. These are not normal aircraft. As 1944 progressed, the Thunderbolt's ground attack capabilities added another dimension to its legend. Beginning in March, many P-47 groups began carrying 500-pound bombs or rocket projectiles, turning the massive fighter into a devastating attack aircraft. Its 850 caliber machine guns proved ideal for strafing attacks against German vehicles, trains, and airfields. The robust airframe, originally designed to withstand the stresses of high-altitude combat, proved equally capable of absorbing ground fire. Major General Elwood Pete Quesada, commanding 9 Tactical Air Command, described the Thunderbolt's impact. The P-47 has transformed our tactical doctrine. Its combination of firepower, bomb load, and durability makes it uniquely suited to battlefield interdiction. German ground forces now move in constant fear of air attack. We've severed their supply lines, destroyed their reinforcement capability, and forced them to operate primarily at night. The statistics of destruction mounted relentlessly. Between D-Day and VE Day, P-47s of the 9th Air Force alone were credited with destroying 6,268 trucks, 895 tanks, 854 locomotives, and 9,880 rail cars. The economic impact on the German war machine was incalculable. Surviving Luftwaffe records contain increasingly desperate assessments of the situation. A Luftwaffe intelligence report from September 1944 stated, "American fighter bombers now dominate the battlefield to a depth of 150 kilometers behind the front lines. Daylight movement of any military equipment is effectively impossible. Rail transportation functions at 15% of required capacity due to continuous attack." German Field Marshal Gerd von Rundstedt summarized the situation more bluntly in a message to Hitler. "The enemy's complete air superiority is the fundamental cause of all our difficulties. No reinforcement or supply movement can take place by day without prohibitive losses." For pilots on both sides, the psychological dimension of this transformation was profound. Lieutenant Gordon Graham of the 365th Fighter Group recalled, "By late 1944, we owned the sky. We would fly at minimum altitude, sometimes below treetop level, and German anti-aircraft batteries would often hold fire rather than reveal their positions. They knew that for every P-47 they hit, 5 more would arrive to exact vengeance." From the German perspective, Hauptmann Josef Wurmheller of JG-3 expressed the frustration felt by many Luftwaffe pilots. "We are fighting an industrial colossus with craftsman's tools. The Americans lose 10 aircraft and replace them with 30 the next week. We lose 10 irreplaceable pilots and their aircraft and receive perhaps 3 replacements with half the necessary training." Even more telling was the assessment from Field Marshal Albert Kesselring, German commander in Italy, who wrote in his post-war memoirs, "The P-47 Thunderbolt represented a revelation of American industrial philosophy: overbuilt, straightforward, and produced in overwhelming numbers. These were not normal aircraft designed with the typical European emphasis on elegant engineering solutions. They were machines designed to be manufactured by the thousand, to absorb punishment, and to deliver it in equal measure." 8. The enduring legacy. As the war in Europe drew to its close in April and May 1945, the final tallies revealed the Thunderbolt's extraordinary contribution. Republic Aviation had produced 15,683 P-47s, the most of any American fighter in history. 8,200 of these had served in the European theater, with the remainder deployed to the Pacific and other fronts. The aircraft's combat record was equally impressive. P-47s were officially credited with destroying 7,643 enemy aircraft in air-to-air combat, along with another 3,752 destroyed on the ground. The ratio of aerial victories to losses stood at an astonishing 8-1, the highest of any American fighter type. More revealing was the human cost. Of the 5,933 American fighter pilots lost in the European theater, only 27% had flown P-47s, despite the type representing 41% of fighter sorties. The Thunderbolt had delivered on Kartvel's promise to bring pilots home. Robert S. Johnson, whose half-wing flight had so dramatically demonstrated the Thunderbolt's survivability, finished the war as the second-highest-scoring American ace in the European theater, with 28 aerial victories. He continued flying Thunderbolts until the end of hostilities, accumulating 227 combat missions without ever being shot down, a testament to both his skill and his aircraft's durability. In July 1945, as Republic Aviation began the transition back to civilian production, Alexander Kartveli received a letter from General Karl Spaatz, commander of U.S. Strategic Air Forces in Europe. It read in part, "The Thunderbolt you designed played a decisive role in winning control of European skies. More importantly, it saved the lives of countless American airmen who would otherwise have been lost. No aircraft designer can claim a greater achievement." The Thunderbolt's influence extended beyond World War II into the foundational principles of American combat aircraft design for decades to follow. Its emphasis on structural strength, systems redundancy, and pilot protection became standard features in subsequent generations of fighters. The A-10 Thunderbolt Zweihundert Attertoins, Genantoi II, designed in the 1970s and still in service today, deliberately echoed not just the name, but the survivability philosophy of its World War II predecessor. The ultimate validation of the P-47's design philosophy came from those who faced it in combat. Luftwaffe General Adolf Galland, who had once mocked the massive American fighter as a flying safe, offered a different assessment in 1973. The Americans designed the Thunderbolt with the understanding that it is better to bring back a damaged aircraft and pilot than to build a new aircraft and train a new pilot. It was an industrial approach to warfare that we could not match. We laughed at the P-47 when we first saw it. We stopped laughing when we realized it could absorb our best shots and still fly home. For Robert Johnson and thousands of other Thunderbolt pilots who survived seemingly fatal damage, the massive fighter represented more than a machine. As Johnson wrote in his memoir, the P-47 was not just an aircraft. It was a promise kept, a promise that if you did your part as a pilot, it would do everything humanly and mechanically possible to bring you home. When half my wing vanished over Hanover that April day, the Thunderbolt kept that promise. No pilot can ask more of his aircraft. The transformation from derision to respect, from laughter to grudging admiration, demonstrated a fundamental truth about modern warfare that extended far beyond a single aircraft type. American industrial might, engineering pragmatism, and willingness to sacrifice elegance for functionality had produced not just a remarkable fighter, but a paradigm shift in how air warfare was conducted. When Lieutenant Robert Johnson limped his half-winged P-47 back to England on that April day in 1944, he did more than survive an extraordinary ordeal. He validated a design philosophy, exposed the fundamental weaknesses in German war production, and demonstrated that in modern industrial warfare, the nation that builds aircraft capable of bringing damaged planes and pilots home will ultimately prevail against those who cannot. The Germans had indeed laughed at the ungainly P-47 Thunderbolt when it first appeared in European skies. But as Johnson's Thunderbolt proved on that April day over Hanover, and as thousands of other pilots would discover in their own moments of desperate need, the last laugh belonged to the massive American fighter they called the Jug.